Naive Bayes. Naive Bayes is a probabilistic classifier based on Bayes' theorem, which assumes that the features are conditionally independent given the class label. Despite this naive assumption, it often performs well in text classification and spam detection tasks. Let's go ahead line by line in writing the code for implementing a naive Bayes classifier using the Gaussian naive Bayes algorithm in Python. I'm going to start with a new file, empty file here. We're going to start by saying import the necessary libraries. From sklearn naive Bayes import Gaussian NB, which imports the Gaussian NB class from scikit-learn's naive Bayes module. Now, Gaussian naive Bayes is a probabilistic classifier based on Bayes' theorem, assuming that each feature follows a Gaussian, which is normal distribution. It is particularly used for continuous data. Next, we're going to do sklearn.model selection import train test split. This imports the train test split function, which splits the data set into training and testing sets, allowing for model evaluation on unseen data. Next, from sklearn model or metrics, import accuracy store and confusion metrics, which imports the accuracy score to calculate the model's prediction accuracy and confusion metrics to evaluate the model by showing counts of true positives, true negatives, false positives, and false negative. Next, let's import numpy as np, which imports the numpy library, which provides support for numerical computations and array manipulation in Python. Let's go ahead and pick up our sample data, which is same as the previous project, hours studied and grades versus pass file. So we have x equal to np array, which defines the feature data x as a numpy array where each element contains two values. The first value represents hours studied by a student. The second value represents prior grades, which are percentages. The shape of x is 10, 2, meaning there are 10 examples rows with two features which are columns. Y is equal to np array, which defines the target data y as a numpy array containing binary outcomes. 0 represents fail and 1 represents pass. This is a binary classification task, which is in our case ideal for Gaussian naive Bayes classifier. So let's go ahead and split the data into training and testing sets. So we'll write the code for that, which is same as before. Nothing has changed here. What it does is it splits the data into into training and testing sets. X train and Y train are used to train the model. X test and Y test are used to evaluate the model's performance. The test size is 0.2, which specifies that 20% of the data should be used for testing, while the remaining 80% used for training. Now random state equal to 42, which sets a seed for reproducibility, ensuring that each time the code is run, the same data split is generated. Next, let's go and initialize and train the model. Model equal to Gaussian NB. This initializes the Gaussian naive Bayes classifier. This classifier will assume each feature is normally distributed and will calculate probabilities based on this assumption. You're going to say model.fit x train y train. This trains the Gaussian naive Bayes model on the training data x train and y train. During training, the model calculates the mean and variance of each feature and each class pass fail to define the Gaussian distribution used for prediction. Now, using that, let's make the predictions. We use the model and say predict. This uses the trained Gaussian naive Bayes model to make predictions on the test set x test. For each data point in x test, the model predicts either 0, which is for fail, or 1 for pass based on the highest calculated probability for each class. Next, let's go and evaluate the model. To evaluate the model, I'm going to use the accuracy score and the confusion metrics. The accuracy score calculates the accuracy of the model by comparing the actual values y test to predicted values y pred. Accuracy is the ratio of correctly predicted instances to the total instances in the test set. Confusion matrix, on the other hand, computes the confusion matrix for the model, which provides a breakdown of true positives, which are correctly predicted passes, true negatives, which are correctly predicted fails, false positives, which are incorrectly predicted passes, and false negatives, which are incorrectly predicted fails. Next, we'll go ahead and print accuracy and print the confusion matrix. So this code demonstrates a full workflow for using Gaussian naive Bayes to classify students as passing or failing based on hours studied and grades. The model is evaluated using both accuracy and a confusion matrix, providing a comprehensive view of its classification performance. Let's go ahead and run this. I'm going to open terminal, clear the previous one, and say Python naive Bayes, and it will give me accuracy and the confusion matrix. That's perfect. Again, if you had any problems following along or implementing this, let me know. If you have any comments or questions, let me know too, and I'll get back to you.